So an atom is the smallest unit of matter that still retains the properties of an element. So here I'm showing you the element helium. And if I go down to a very single atom, it will still retain properties of what makes that noble gas, helium. So what are some properties of an atom? Some components that gives us these properties of the element. Well, we actually have something called subatomic particles. So these are smaller than the atom since they are part of the atom. And we actually have 3 of them that I want to show you. So here I have an atom pictured, this circle looking structure here, and appreciate that an atom is actually 3D and not just flat on the surface. But here I have an atom represented by the circle. In the center of that circle, we have 2 different subatomic particles that gravitate towards the center. This is termed the nucleus of the atom, the center of the atom. And here you will find protons. Here are actually 2, since I'm discussing helium. And protons are named so for their positive charge, P for positive. They're located in the nucleus. In addition, I also have neutrons in the nucleus, and neutrons have a neutral, N for neutral charge. And what I mean by that is that they have no charge at all. So I can appreciate here the nucleus of an atom has a positive charge because only those protons have a charge. The neutrons don't have any. In addition, the last subatomic particles are these floating electrons, and they are not located in the nucleus. They are actually located around the nucleus, and actually it's this space that exists around the nucleus, not necessarily a defined circular space, but they're found floating consistently, circling around the nucleus in what's termed an electron cloud. And what an electron cloud is actually our best guess at where we can find those electrons. And we're pretty good at determining where to find them. Now, which electron we're talking about is going to determine how they orbit the nucleus. Here I have 2, very simple helium atom that's floating around. Appreciate that these electrons are shown on scale much smaller than these larger protons and neutrons. Well, they actually are quite small, and they do not have a mass associated with them, which I'll point out in a bit. And electrons, in addition, have a negative charge associated with them. Okay, so those subatomic particles then give us some properties that we can discuss and some new terms that are coming into play. So an atomic number is going to tell us the number of protons of an element. The atomic number is usually on the top part of the elemental area on the periodic table. That square area is usually on the top. It might be on the right hand side depending on which chart you're referring to. Here I have the atomic number in the middle, and the atomic number I'm showing you for carbon element is 6. I will always give you the atomic number. I don't want you to memorize atomic numbers for elements, but it's actually easy to know them because the atomic number goes in order from the start on the chart. That's one of the ways the elements are organized on the periodic table of elements. It's by their atomic number. The atomic number tells you the number of protons, and only the number of protons that you'll find. It gets a little bit more elegant, and we're not going to go into too much detail in this class. I want you to know the atomic number is the number of protons. The atomic mass, then, you might also see this in different texts or sources as the mass number. It's the same thing. The atomic mass is going to be the sum of the protons and the neutrons in the nucleus. Both of those subatomic particles have a mass associated with them that contribute to the overall atomic mass. Appreciate that electrons are not contributing to the atomic mass. That's because they don't have a mass. Very, very, very tiny subatomic particles. So here's a question that I can give you given these different concepts, knowing what atomic number and atomic mass is and how to find certain subatomic particles, namely protons and neutrons, using these 2 components of an element. So we have an atom of mercury, given that the atomic number is 80. So I'm going to go ahead and write that information down before I go further. So recall that the atomic number is the number of protons. And I'm going to just write shorthand lowercase p with a positive sign, and that tells me protons. And that is all the atomic number is telling you. And in the question, it's telling you that that number is 80. Well, then that means that I have 80 protons. Okay. Next up, we have an atomic mass of 200. So here's my atomic mass. And that's different. That's telling you something different. That's telling you the number of protons. So I'll go ahead and put that there. But in addition, it's also telling you the number of neutrons. I'm going to write a lowercase n and a little o at the top to tell me that neutral neutron is also being added. Both the proton and the neutron, those two subatomic particles that are located in the nucleus of the atom, have a mass. And the summation of both of them tell you the atomic mass. Well, in the question, you're telling me that that equals 200. Okay. So this atom has what? I want to know the number of protons, and I want to know the number of neutrons. I have two different numbers, an atomic number and atomic mass. Let's figure that out. I'm actually going to erase that. So I already know the number of protons. The atomic number tells you this. That number's 80. So already we can X out B and C, because only option A and only option D tell me 80 for protons. But I want to know the number of neutrons. Is it 120 or is it 40? Let's go ahead and do some quick math to figure that out. If I subtract, let me actually get a new page to show you this. If I actually take the atomic mass and subtract the atomic number, that'll give me the number of neutrons. Well, that's because the atomic mass tells you protons plus neutrons, my positive charge and my neutral charge, and the atomic number is just the number of protons. So if I actually subtract that proton number, I get just the number of neutrons using algebra. So I'll go ahead and do that. My atomic mass from the previous question, if we look at that, that's 200. So I'm going to go ahead and do 200 and subtract the atomic number. That's 80. That's going to give me the number of neutrons. 200 minus 80 is 120. That is my number of neutrons. That is option A. Final answer.